to start our discussion about ACI by first looking at another device. In fact, I'm going to start my foray into Cisco solution to software-defined networking by looking at a Nexus 7000 series switch, so a 7K. Now, the 7000 series switches, whether I'm talking about a traditional 7K or talking about a 7700, they still function based on the same rules. We have a number of components, one of which is we have a chassis, and that chassis contains power supplies and everything necessary to power on any of the other devices or components that I actually insert into that chassis. The other part is that I need a brain. I need something to govern and to manage both the configurational capability as well as the runtime information associated with the configuration that's being made on a given switch. And we call that the Supervisor Module. Now, the other thing that we also understand or need to focus on is the fact that if I want to have port density and port capability and functionality integrated into this switch, what I need to do is I'm going to have to insert one or more line cards. And it's important to note that those line cards are normally going to have their own application-specific integrated circuits, or ASICs, that are going to allow them to be able to function at layer 2 and layer 3 and do so as fast as possible. In other words, that means that these devices are going to support the idea of line rate forwarding. Thus giving me optimum amount of bang for my buck. Now, the moment that I start dealing with line cards, I also need another component, because I need more often than not to send communication between line cards, and in the majority of the devices that we have that are 7K, we use something called fabric modules to accomplish this task. Another term for a fabric module would be a crossbar module. So I want to kind of illustrate what I'm talking about and put together this 7K on the light board so that we can look at the concept of what we best refer to as distributed networking. Now, why do I say that? Well, let's look at it. So first of all, I'm not really going to spend any time talking about the chassis, because the chassis is basically the box that contains the ecosystem. The ecosystem is going to be the supervisor modules, the line cards, as well as the fabric modules. Now, when we do this, what I'm going to do is I'm going to just simply draw the box. But I'm not going to draw the chassis itself. What I'm going to do is I'm going to draw the line cards that are going to be inserted into the chassis. So this is, let's just say, line card 1. Line card module 1. And it's important to understand that line card module 1 is going to have a series of interfaces that are going to be part of its physical makeup. It's also very important for us to understand that these interfaces are going to have access to some type of resource on the line card that's going to allow them to be able to manage traffic. So all of these devices are going to ultimately end up going to that device, and that device in Cisco's configuration we call a SOC. Now, SOC, S-O-C, stands for System on Chip. Now, this is really important because I'm going to have, and I'm not going to draw all of them, I'm just going to draw two for the purposes of conversation. I'm going to have multiple SOCs, multiple chips, multiple ASIC-driven components that are going to allow me to be able to send and forward data on this line card. So the ultimate comparison here is if I have a device, let's just say I have a host, And I'm going to call this host host 1, and that host is connected to this interface, which makes it part of SOC-A. We'll go ahead and call this one SOC-B, just as a talking point. What we need to understand is that as data comes into this line card, it needs to go somewhere. Now, the first condition that I want to discuss is if it needs to come in and go out of an interface that's part of the same SoC, the same system on chip. A lot of times I'll actually say switch on chip, because to me this is like a discrete switch, this is like a discrete switch, but understand that the actual term is system on chip. So let's say I have a second host. I have host 2, and host 2 is connected to this interface, which is part of the same SoC. Well, in this scenario, what will end up happening is the data that needs to travel will actually be able to be managed by the local ASIC, by that SOC. Now, the benefit here is the fact that it's all containerized. And we're also making some assumptions that these two devices can talk to one another. But that begs the question, what if I have a third device? Let's say I have host 3. And let's say host 3 is connected to this interface, which is actually part of SOC B. And let's assume that host 3 that is directly connected to SOC B needs to talk to host 1 that is directly connected to SOC A. Well, every line card is also going to have integrated into it a construct called a local fabric module. And each SOC will be connected to the local fabric module. Now, the benefit here is as data comes in from host 3, it hits SOC B. From SOC B, it goes to the local fabric module. The local fabric module then in turn can actually send that data back to or out to SOC A, and then the data can go through. And you can see that everything here is containerized. And everything is bound to this line card. But that begs the question. The question is what if I have more than one line card? Well, let's say, a 7,000, let's just pretend we have a 7,010. So I've got 2 supervisor slots in that box and 8 line card modules that I could insert. And let's just say this is module 1, so that's the first module. So what I'm going to do is I'm going to pretend, because in this model 5 and 6 are the soup module slots and you can't put anything else in there, but what I'm going to do is I'm going to pretend this one is module 1, but let's also pretend that I have another line card, and that line card is going to be in another slot. In fact, let's go ahead and just say this line card is going to be in slot 7. So it's one right after the second supervisor module. And it's also important to understand that this line card is going to have interfaces. Those interfaces will be attached to SOCs. I'm just going to draw 2. So this is an SOC, this is an SOC, and we also know that every line card is going to have its own integrated fabric module. So we'll just say fab here, connected like so, connected like so, like so, like so, like so, like so, like so, like so. I'll draw a 4th interface in here. And now I actually have line card 7 interacting here. Same scenario applies. If I have a host here, and that host is connected to this interface, let's just say host 8, and that device needs to talk to any other component, the same rules applied as applied to this line card. It would go to the SOC. If the device is on the same SOC as this host, it'll actually come in and go out. If it needs to travel between SOCs inside the same line card, it'll hit the fabric module. These are what are referred to as Fab 2 modules, by the way, in modern devices. But the whole goal here is that that'll actually be able to come out. But the question is what if host 8 needs to talk to host 3? what we need to do now is we need to discuss the missing components. So first of all, what we're going to do is we're going to highlight the fact that these line cards are going to actually be inserted into my chassis. Remember that box I did not draw? Remember, these are all part of the same physical chassis. Now, these cards need to be able to interconnect with one another. Well, the interconnectivity that we're going to be setting up is going to be connecting to a module that inserts into the back of the, let's see how best to do this. Bear with me just one moment here. So I will draw it like this. So I'm going to have a module that I'm going to actually insert into the back of the chassis. That module is going to have a position where line card 1 will be attached, 2, 3, 4, 5, 6, 7, and a slot where 7 will attach, line card 7. So in this scenario, this card will actually be connected to this slot, and this card will actually be connected to this slot. And now, as data needs to move between cards, it can actually traverse this fabric module. That's what we refer to this as, a fabric module. And again, it's called a Fab 2 in that it can handle 220 million packets per second, or 220 million packets per second. And it's important to understand that we're going to have multiples of these. So in, say for instance, a 7010, I am going to have the capability of having, let's just say, up to 5 of these. Now in my lab, I only have 2 per chassis. 1 in case I lose one. So we'll just emulate what I have in my lab. So I'm going to have 2 fab modules. Now what that means here is I get the capability of being able to implement things that is going to prevent head of line blocking. And this is all based on, again, what is called crossbar interconnectivity. And it's important and also relevant to us to understand that the crossbar fabric that was built allows me to be able to have simultaneous communications by providing ample backplane crossbar fabric, and it was created by a man named Charles Kloss. And oddly enough, when we start talking about ACI, we're going to find that the ACI is a leaf spine design, and the ACI ultimately at the end of the day is a Kloss architecture. Now there's one other component to this that I want to spend some time talking about, and that's going to be the Supervisor Module. Because I've covered the fabric module, the crossbar modules, I have covered the line card capability, and we've mentioned the fact that the chassis handles or contains the ecosystem inside of one box, and if I had multiple chassis, that means I would have multiple networking ecosystems in each box, and if I wanted each of those ecosystems to communicate to one another, I would then have to connect them through other network resources, routers or switches. But when it comes to the Supervisor Module, the Supervisor Module is very, very important, because the Supervisor Module, so in our labs we have SUP 2E modules. These SUP modules, of which I have 2 of them, provide the intelligence. So if I want to configure any of these components, if I want to look at the runtime information associated with any of these components, I do so by interacting with the Supervisor Module. So it is my single point of control. If I have 100 switches, that means I'm going to have at least 100 active supervisors, preferably 100 active and 100 standby. So I'm going to have 100 active supervisor modules. And for every supervisor module, I'm going to have an IP address assigned to the management 0 address. And that's even without virtualization, because with virtualization, or what we call VDCs, inside of a 7K, I'm going to have even more. But in this instance, I have 100 IP addresses, which means I have 100 points of management. However, I manage every line card inside of every chassis from the single IP. So from, let's say, in my lab, 10.1.0.71 would be the management IP address for chassis 1. Now, in this configuration, once I'm in, I can manage anything that's part of this chassis. So just keep in mind, in this scenario, everything is connected and everything is managed by the Supervisor Module, to include something referred to as virtual outbound queuing. So the object here is if this line card needs to send resources to this line card here, what's going to end up happening is to prevent dropping traffic, we're going to rely on the Supervisor Module to be able to ensure that we can query the device to see if it's able to receive it. So in other words, let's just say this card, let's say this sock had the capability of receiving 20 or 200 whatevers. And this line card had the capability of being able to send 500 whatevers. So just think of these as placeholders. So I have 200 spaces to put something. Here I have the capability of being able to send up to 500. What's going to end up happening is that the Supervisor Module is going to ensure that I do not have the capability of oversaturating this device. Then what's going to end up happening is I am arbitrarily going to lower my output capacity to 200 such that I will always match what this guy can receive, thus preventing the idea of dropping, and also keep in mind that we're going to have to buffer traffic. Now, when it comes to the Supervisor Module is not in the data flow. The Supervisor Module is there for the sole and express purpose of managing the box. And since the SOCs exist inside the infrastructure, each line card has the capability of being able to function in the event of certain scenarios and situations. Now, again, when we start doing this style of implementation, we're relying upon everything that we ever had in iOS. We're just doing it differently using a different operating system called NXOS. And that means that we need to actually take this and apply it to ACI, because this is the way that I visualize the way the ACI works. Because we have to understand just a few more components. One of them is the fact that we have to focus on the planes of operation. So remember, we have the management plane. The management plane is how I'm going to access my devices. We have the control plane. The control plane is going to be how I learn things. And we're going to look at the impact of that when it comes to normal devices and how things change when we start looking at ACI. And then ultimately we have the third element, which is going to be the data plane. That's going to be where data actually moves. Now, when we start looking at this, we're going to have to understand the behavioral differences of how ICLOS infrastructure works. We're also going to want to learn how the ACI takes this theme of distributed networking and applies it such that the ecosystem is no longer containerized in a single chassis. The ecosystem is going to be defined via what we call a pod. And we'll have the capability of being able to have multiple pods, as well as the capability of being able to stretch our fabric, as well as the capability of being able to implement something called multi-pod. So I'm hoping that you guys rewind this, take a look at it a few more times, because everything that I'm going to be talking about in the next couple of videos are going to be relative to this. Because if you can visualize this, and this is something that should not be new to any Cisco trained network guy or gal, because this is the way the Catalyst works. It has Supervisor Modules like the CAT 6500. This is the way the Nexus works, and these are all well-known and established platforms. So at the very minimum, we should all have a theoretical understanding of this idea of distributed networking and distributed ASIC optimized forwarding. So with that being said, I'm going to stop here, and I'll see you guys in the next video where we're going to talk a little bit more about management, control, and data planes and the way they impact traditional networking. so we can more better understand how software-defined networking, or Cisco's solution to software-defined networking, modifies that behavior. I'll see you guys in that video.